Hey, welcome to today's Detect.sh podcast. If you're new to us, we're a community of people focused on open problem detection and resolution in our software applications. And I'm your host today. I'm Tony Meehan. I'm CTO and co-founder of Prequel.dev. And I'm honored, and I do mean I'm honored today to introduce our today's guest. He has well over 10 years of experience in eBPF, C++, Go, Kubernetes, Linux security. He's the co-author of Linux Observability with BPF. Pick it up now while you still can. We'll definitely talk about it today. He's an open source legend. He was a maintainer for the CNCF Container Native Runtime Security Project, Falco. He's been a curator for the Moby project, which was an open framework to assemble specialized container systems in Docker, as well as Dr. Captain. He maintains and created IOVisor's kubectl-trace. It's a plugin for kubectl to allow you to run BPF trace programs in Kubernetes. I've used it a bunch. It's awesome. And I've had the pleasure of working alongside this amazing person during our time together at Elastic, and count him as a true friend and someone I really do look up to in the community. So without further ado, ladies and gentlemen, please do me a favor and welcome Lorenzo Fontana to the show.
Yay.
Thank you for joining us, Lorenzo.
Thanks, Tony, for the intro. I think I'm gonna, record this and, watch it when I feel down. It was, like very, very good. Thanks for doing it.
I appreciate that. It's always fun hanging out with you, and whether or not we're recording it, it's always a fun opportunity for me to get a chance to talk with you. And today I'm glad we get to share it with a bunch of people. Just to give you a sense of today's kind of podcast, definitely want to talk about your eBPF origin story and kind of how you got started. Definitely want to talk more about some of the open source projects that you've been involved in. I definitely want to talk about the book. Curious to kind of hear your thoughts and perspectives on building and troubleshooting applications, especially kind of these days. And then maybe for the audience, I think some good things that you can probably take away from today's session will be around eBPF, its applications to problem detection, just discussions around troubleshooting. And then maybe as a final reminder, today's podcast is actually brought to you by Prequel, company bringing detection engineering to reliability. So super excited to be here today. And maybe we can get started, Lorenzo, kind of on your origin story. Would love to hear a little bit more about your background, your journey into tech. Give us the Lorenzo origin story for those of us that don't know you.
It is very boring, but I'm gonna try to tell you. So literally, I was working as a software engineer in Italy. I don't know, in 2017 or something. And I mean, I've been working for many years before, but the journey with the BPF, which is I think what it's important for everyone here, is started around the time I used it before, like in the couple of years before that, but really like not in a, I'm really, knowing what it does or what it is way, right? Then what happened was that I had the opportunity to start working as a software engineer, as an SRE mainly, at Influx, where we were working on InfluxDB 2.0 that many people probably are familiar with. And one of the problems that we had with working on that, at least from my point of view, because maintaining the infrastructure and making it work was like kind of central there, was the Linux kernel couldn't reply or couldn't answer, or any Linux available tool couldn't answer this question. When we write to the file system, when we do, the actual write, what is the block size? Like observing what is the block size, observing how the file system reacts to that block size, like to optimize, writes between different kind of, disk, SSDs and VMAs. Like when you write a database, that's quite important because you don't know where it's going to be deployed, right? And so I remember working with the team on this problem, and we started working on a Kubernetes cluster mainly because, like, Kubernetes is, a good solution for building a cloud, database solution. And literally starting looking for alternatives, starting looking on how to do it. eBPF, right? We started writing custom programs. We started doing, so many things. Then at some point, and there are so many talks in the internet about this, like you can go on YouTube and look for my name. You're gonna find an Italian politician, but it's not me. Like my name. And then you're gonna find my talks as well. Maybe look for my GitHub name, FNTLNZ, which is like terrible, but I chose it like 10 years ago. And then you're gonna find these talks at KubeCon North America and other KubeCons about what we were doing. And essentially, we discovered that there was BPF-trace, which is incredibly good if you're just getting started with BPF, because it allows you to script BPF programs instead of having to understand how to compile them, how to load them, how to get the data out and everything. So, but BPF-trace will run on a Linux machine, like on a local machine, not on a cluster. So with the team and with my friend Leo, we started thinking about alternatives, and the idea of making kubectl-trace came out. So essentially, just kubectl plugin that schedules the BPF-trace programs in the cluster and gets the data to you. Many people started contributing. Alban from Kimfol contributed a lot, and Dale from Shopify contributed a lot. Like they just made it a lot better. Recently, there are a few new contributors that started renewing it and making things a little bit better. So I'm quite happy about it. And if you're looking to contribute, of course, you're welcome. It's under IOVisor now. BPF-trace has been moved to its own our organization, so we don't know what's going to be the destiny, but for now it's good there. And that's it. After that, I did so many other things I don't even remember, but this was the things that got me started. And after that, there was the book, and been working on Falco. Like Tony will surely, ask me question about those things.
Well, one thing that's interesting to me, we've talked to a lot of people in these podcasts, and I don't know, it's always fascinating to see a lot of the origin stories. They're so different and diverse, but a common thread across all of them is that curiosity to learn more. Like when you're talking about, no, actually, I want to know how big is the block size in the kernel. What's the best way to answer that question? And that led you to this whole universe of eBPF and all the awesome things that you've been doing in there. So that's, I think, pretty fascinating. But maybe one thing that folks on the podcast listening now maybe don't have as much familiarity with eBPF. Maybe they've heard of BPF. So I wonder if maybe you could take a minute to kind of break down what is eBPF. What makes it so useful and so powerful for monitoring and tracing Linux workloads, and how does it work? And yeah, break it down for us.
Yeah, first of all, more than just that, I want to say this thing. For me, at least, knowing eBPF, knowing BPF, getting involved into that was more about understanding better the kernel, which is, I think BPF is the only subsystem in the kernel, the only, part of the kernel that allows you to get that, breadth of knowledge. Why? Because essentially you want to look at what happens, right? So you go and I know you need to look at what happens at the networking side, learn about traffic control, learn about XDP, learn about network interfaces, how protocols are made, all this stuff. You want to learn about how a process is running. You get to learn how the stacks works, how the memory works, the memory manager work, how tasks work, all this stuff. You want to know about the file system, you get to know how the VFS works. And like before, like how do you know how that works? Unless you wrote a kernel module or you are heavily involved in kernel development, or you look at the code a lot, but one of those things. But the entry point was like, I would say, a lot farther away. Now it's with the BPF, I think it's, it gets closer to the people that, want to learn as well. For me, this is the most important thing. Regarding the terminology, BPF is now called, I would say, I don't know if everyone agrees, but it's classic BPF. Like you can see it referred as CBPF. And the BPF is extended BPF. BPF is the term that I've seen other use in a way of like referring to BPF as eBPF, like everything BPF, right? So even though the BPF term, initially was used toward the original version, what was only meant for network packets and was like a very simple, set of instructions and just a simple registry that will get updated with simple operations. Now it's a little bit more complicated with a lot of arithmetical operations, a lot of registers, a lot of different a very wide instruction set. So it's a little bit more complicated, but and allows you to go in places where BPF wouldn't go, of course, right? So you can not only look at what the network does, but what the file system does, what every kernel function does, what every function in a program does. Like you can essentially attach with so many things that like sometimes I don't remember. No, I can safely say that I remember. If they added any new ones, I don't know at this point. And BPF, like maybe you've been using TCP dump, right? So TCP dump, Wireshark, all those, they use BPF inside, right? Essentially, they write BPF for you, BPF, classic BPF for you. And they execute it and filter the packets that they capture from the network interface using BPF, which is interesting. There's a flag in TCP dump, I think -D, that you can use to see the instructions, which is cool. And that's it.
Yeah, and it's funny, like my introduction to BPF actually was in the early 2000s using that exact TCP dump flag, compiling my own kind of complicated filters. Basically it's like almost like a virtualized like assembly language kind of experience. And then yeah, years later when I learned about eBPF and what you could do in Linux kernel, I was like, oh, that's really interesting. And I think maybe one thing that I would love to hear you maybe talk a little bit more about is what is it about writing eBPF programs that makes it maybe safer to do this introspection in a Linux kernel than maybe writing just a Linux kernel module?
Oh yeah, that's a very common point. It's one of the selling points of eBPF as well, right? First of all, when you write a kernel module, you are actually in the kernel execution path because the kernel loads your code and it executes it. So you can panic the kernel, you can create other issues, you can introduce security issues, you can introduce problems that you will never be able to see safely by just testing it. You don't know, like essentially you are in a gray area that unless you're expert in what you are doing, it's much more easy to create issues with the kernel module than with an eBPF program. Of course, there have been problems with BPF as well, like a few instances where BPF was breaking Linux machines in the past. Can happen. The maintainers are very good at trying to not make it happen. There is a system in BPF they call a verifier that is very annoying, and you fight it really don't understand what it wants because like it just spits out some stuff that only the elect people understand. And so I don't understand it. And then, but what the verifier does is that it makes sure that your program doesn't, interfere with the kernel, doesn't, create issues with it. It doesn't do, for example, unbounded loops. It doesn't, take the whole CPU because remember that when you, for example, want to observe what a kernel function does, because you want to see when it gets called, right? You can put a key probe, right? When you put it, you're actually going into the execution path. So you are there observing what happens. if you will be able to stay there for a second, maybe the function call that you are monitoring is, I don't know, VFS read, which is the function call that, is done every time you read from the file system, the system hangs, right? So the verifier is responsible for that. And the verifier is extremely complex. The maintainers are, just crazy at maintaining it. They just did an incredible job with it. And it's what, sometimes causes those problems where the verifier doesn't catch something and you will end up in a bad way. But it's very rare. Like it's so rare that I wouldn't be worried about it if I would think about using VPF. Like it's a lot less possible than you writing your own kernel module and crashing the kernel. So
Yep, and the fights that you have to sometimes get into with a verifier up front, totally worth the cost because of all of, like you just said, the safety and performance guarantees that you get with this observability through eBPF is sort of unparalleled, especially because you don't have to modify any applications to get the insights. You can just look directly in without changing any code, which is I don't know, exciting. I think it's really cool. But you're right. There's definitely a lot of fights that you have to put up with in the verifier, but it's worth it to pay that cost up front. And now you're also right that this has been around in the Linux kernel, what, at least I think it's almost 10 years, if not longer. And a lot of improvements have been made into it. It's you're right, the maintainers have been doing a great job, but certainly, years ago it wasn't always that way. And I think you've got kind of an interesting story about several years ago you found something in the verifier. Is that right? And I would love to hear that story.
yeah, I did a mistake. I want to apologize again to the kernel maintainers for the subsystem. I did a mistake. Literally, I was working on Falco. I think it was at Loris' house. Loris is one of the first people that created Falco, and the libraries libscap and libsysp that are used in Falco. And I think it was at his house, and it was like, can you look at this issue? Right? Looked at that issue, and I really, didn't look at it because it was very hard to reproduce. Like it was only happening on a specific 4.14 kernel that I couldn't care less about. And got a VM, reproduced that issue. All of a sudden, the VM panics. So I wrote, simple reproduce the VM panics. Just first, like, silly me. Twitter, oh, I'm able to kernel panic a kernel with the VPF. Like, shouldn't have been doing that. Like, it was very bad. And, I paid the toll because, like, after that, I received, I think, on Twitter, I think, 10 messages a day from people asking how to reproduce it, which were sketchy profiles, trying to, tell me, like, tell us, right? Of course, didn't tell anyone. Then I got emails from the maintainers asking me what was going on, why didn't you tell us? Of course, it's a good practice to just inform them first. I didn't do it. I learned the lesson. And of course, then got fixed the right way. It was just, it was very difficult to catch. That's everything I can say. You literally would see the generated the BPF code, and you couldn't see the difference after the fix. It was very, very, very subtle. But then
Oh.
you got, but you will be able to panic. Then after that, like few similar techniques have been used to do privilege escalation, do all that kind of stuff. And I can say that after that period, right, the real I think that the main issues have been fixed, and now the verifier is a lot more capable. Not that it wasn't, but now it's very, very capable of making everyone safe. And just as a reminder for everyone, next week there's a BPF summit. So I think that a few of those people that I mentioned here are gonna be there. It's virtual, unfortunately. I would really love to go there in person, but I think that people are interested in understanding more, because as Tony said, like it's about going in depth. When you approach technology like eBPF, you really want to go in depth, right? Because otherwise, why would you bother like learning all the stuff to do what, right? And it's always nice. Like there are a few things that you can do that, like when you look at them the first time, they blow your mind. Like for example, simply there's there's a repo in IOVisor called BCC that is literally a collection of tools, BPF compiler BPF compiler that has a tool inside called bash read line, if I remember correctly. Bash read line literally allows you to see all the commands run on bash by looking at what happens at read line, which is the library that's used to get the input from the terminal. And when you look at it the first time, you say, am I even safe on this machine? So with BPF compiler collection, you have all those tools, and now all those tools have been rewritten to use the newest, BPF libraries. So they are like very interesting to look at, because you have a lot of code to look at to understand what you can do with eBPF, right? And the other thing is like when people, because like for a long time, since the verifier was so strict, people will say, BPF is not Turing complete. Like you cannot do Turing complete things. Nowadays, like there are so many new things. Like you can call the BPF program from other BPF program with tail calls. You can do certain kind of loops. So you can do advanced things. For example, you can parse protocols. You can parse HTTP. You can parse DNS. There are few people doing that. There's a lot of work around there that people are doing. And nowadays, it's a very good moment, I would say, to start and understand why, because the tooling is a lot more mature. It was even like 2 years ago, right? Or not talking about 5 years ago. That's why, like some, when some people read the book, they, say like, now it's not like that anymore. I agree, right? It's like if you will ever, get the book, it contains a few useful information still, like about how traffic control works, about how XDP works, that were the result of the understanding that my co-author and I had about it, because there was nothing written back then about that stuff. Now there's more stuff, but like how you use it, like it's a little bit different now. Like now it's like simpler, not simpler. Like now it's, I would say, easy, right? Before it was still easy, but um, you will need to know where to look at, right? It wasn't difficult. It was just hidden, right? Now there's all the stuff around, like the documentation, blog posts. There have been a lot more people interested that wrote content. There's a BPF community. There's a website, eBPF.io, that is, contains a lot of stuff. The same people that are organizing the conference, the BPF Summit. So there's literally, a lot of stuff, and there's there are a few projects like Falco, Cilium, that wrote so much code that you can look at and you can understand. There's the former company where Tony and I worked, Elastic, that recently donated the hotel profiling agent to OpenTelemetry, that contains one of, I think, the most sophisticated BPF program out there that you can look at. That essentially, for many programming languages, it goes in depth into what the program does and gets you profile information for OpenTelemetry, which is mind blowing. Like they, I think that Tony, they even patented some techniques like that. That's a kind
No,
of
it's absolutely, yeah. It's an
yeah.
amazing the fact that it was donated to open telemetry, I think, was made a pretty big dent. I had a lot of people reaching out like, did you see this? And I was like, yeah, this is incredible. I had a chance to use it before it was donated, and so it's awesome that the world can now use it for free. And yeah, I agree. It's probably one of the best continuous profilers that's been ever created. Um, and it's also interesting to like, yeah, the ecosystem really has evolved. Like I was a very early follower of Brendan Gregg's blog, like in early 2000s. And it's awesome that he still keeps it up to date. But yeah, like seeing eBPF and the BCC tools show up there that you were talking about, I think he wrote almost many of them. Um, I used to use GDB all the time to go figure out what something was doing, what a program was doing, or even just pull it up in like a disassembler, like object dump. But now that the tooling around eBPF is so easy to use and so insightful, and also um, performant, that like I often use those eBPF tools as like my first stop to figure out what's actually happening. Yeah, because and also like every security product that does something on an endpoint over the last 5 years has migrated away from traditional kind of K probes like eBPF specifically, because it's way more efficient and just better. Um, yeah, it's the open source community and the contributions they made to eBPF over the last 5 years, especially the last 10 as a whole, is pretty remarkable. I couldn't agree more. And I'm actually maybe to pivot a little bit here around open source and growing communities. You were a maintainer for the CNCF Falco for a number of years, and so maybe for folks on the call that aren't familiar with Falco, can you just give like a high level overview of what it was, what it is, and maybe some of its technical goals?
So yeah, Falco was originally created by SysDig. They decided to donate it. I was employed at SysDig when this happened. And essentially, the reason why this was done was that, this is like a cool thing. This is something that integrated with Kubernetes. Let's donate it to the CNCF. One of the highlights of my time there was that we brought it to incubation, which was like a very interesting thing to see happen. And now I think that they recently graduated. I'm not a maintainer anymore, but I think that they recently graduated it. Yeah, I'm fairly sure. Yeah, I'm sure. Like I know that they graduated it, and they graduated it. So it's pretty impressive the amount of work that the team has been doing there. I'm very proud of them. The project is essentially, when you have a Linux machine, right? You want to know what happens in that Linux machine, but you cannot just know everything that happens, right? You cannot just like, I want to know everything that happens. Why? Because a Linux machine might do millions of operations every second. Like it can do everything, and you have no idea. So you have to come up with, a way to create rules and create, to tell it what you want to observe. Falco essentially allows you to do that. Like it allows you to write rules with the Falco rule set that you can use to monitor the activity in a Linux system. Falco is using a library called libscap or libsins that are coming from SysDig as well. They originated there, and now they are in the community. And those libraries are very useful because they allow you to monitor every syscall attaching an eBPF program to the kernel or a kernel module. So it's like compatible with a very wide range of systems. You can run it on a 3 kernel. I think you can still run it on a 2 kernel, right? So it's crazy.
Oh,
And the format, which is I think a good idea that they had, is it's compatible with the pickup, right? So the SCAP format is compatible with pickup. So you can open those in Wireshark, which is mind-blowing. And the syscalls, however, that's one objection that I was always there, and I think it's still valid. Don't exist for everything. Like, for example, you cannot do protocol inspection with a syscall because, like, for example, when a DNS query happens, there's the syscall that makes the network connections to the port for doing the query, but you don't have like a DNS syscall that tells you this DNS connection to. I don't know if they, changed anything about that, but I think that they improved it a lot. So I think I'm, fairly sure that now there's something that can do it. Or I think that they added a plugin system, so I think this will be pluggable. So I'm fairly happy about the direction that the project took, because they have been able to evolve it in a way that it stays modern. Because that's one of the problems with project in general, not just open source project, that you become outdated very quick. And now with all the waves that there are, AI, blah blah blah, it's a lot faster. So I'm pretty happy about it. Falco is still an impressive project. Like, it's one of the few projects graduated in CNCF, and also it is extremely well made. Like, if you can look at the Falco code, especially the low-level kernel code, is just masterpiece. There are a few people that worked on it, mainly that are very good engineers. The honorable mention, I think, goes to Gianluca Borello, which is the main person that wrote the eBPF program and the kernel module at the start, that then was evolved, and that stuff got added to it. But Gianluca was really really key and was very good at doing it. And of course, everyone has Leonardo and everyone has Mark and Chris Nova, that unfortunately is not with us anymore. But everyone made left their footprint. Now the new folks that are there, that I don't know personally because I left earlier, but I've seen their work, and their work is exceptional. So and also I think that the project has been always good at finding the right people for doing the things.
Yeah.
So
Well,
and
I mean, I guess if you look back on your time on that project, are there things that stick out in your mind as things you're most proud of? Like, when you reflect upon your time with Falco, what are some of those things you're most proud of?
well, one of the things is the ability, right, that the project had on making it consistent to get information, whatever it is, a kernel module or an eBPF program, which is not as easy as it seems, right? And back then, the project was using a few techniques to get this information out that now are just in libraries. Right now, they are easy to use. That, like, for example, the way, like in eBPF, you cannot exceed stack size, so you have to use a map. Now it's easy. Like back then, like there was no way literally for you to understand how that will be working. Like there's no code around there, like where you can look. And that stuff was like majestically put down, and it was just working. And another thing was that in general, we tried, there's even an issue on AWS containers to add these, for example, to Fargate, right? So we were like ready. There's a repo called pdig in the Falco security org, I think is still there. It allows you to essentially do this on Fargate in a way that's done with ptrace. So like imagine like there's the implementation of eBPF, the implementation of kernel module, implementation with ptrace. So essentially, it was like a very cool thing to see. And that implementation was like, I'm proud. I contributed a thing in that implementation that I'm proud of. Essentially, when you, of course, like you're in a Fargate container, right? You can't really do many things like you really are, very contained. And you can only start, like you start your own process, and you are basically there like doing your things. At some point you need to start this Falco process that monitors what happens in that context, right? But how do you communicate with it? Like you open a port, you the idea was to use a Unix socket, right? But then everyone can write a Unix socket. Like it's there, it's in the file system. Like people can mess with it, right? One thing that was cool that I learned there. I think it was 2018, or 2019. I think that I learned that would have been possible because I didn't know, is that when you use a memfd create, you essentially, like, it was just a connection that I'm proud of, like, knowing two different things and put them together to do something else. So when you do a memfd create, you can create a memory area that's a file descriptor. So you literally have the file descriptor, not just the memory area in your program memory layout. And you can use this file descriptor in another process, right? The cool thing is that if you do send MSG and rec of MSG, those syscalls have a specific way for you to move those file descriptors around. So you can literally get this file descriptor done, move it, get it somewhere else, which is very cool. It was very interesting. So literally we will do the file descriptor, do some things, prepare the socket, and then share it only with the process that was supposed to write to that Unix socket. So you literally have the Unix socket, but it's nowhere, right? So you don't have
That's awesome.
the file system.
Yep.
Just have the file descriptor, which is interesting because, like, how do you, like, if you don't know that this possibility exists, you don't even know how. Like, imagine when you want to know if someone is like in your machine. Like, what do? Like, you look at the files, you get the network connections, everything can be hidden, right? Like there is, like, you can hide processes, right? You can hide files, right? So it's literally there are so many techniques that you can use to hide files in Linux machines that are countless, right? So you can
that
hide
is
files,
actually pretty cool.
yeah, or you can hide them in this way, right? So it's
That's amazing. I definitely have checked out that specific ptrace capability in Falco. And this is probably a good time in the podcast to remind folks that are listening. This is your reminder to go do a thumbs up on the Fargate eBPF GitHub issue. AWS has been working on it diligently on the roadmap for a while, and many of us in the community are excited to see that on Fargate. Can't wait. I know you've done it. I know I've done it, and everyone else go do it.
yeah,
Maybe the last thing. Oh, sorry. Go ahead.
literally. I think that when they're gonna do it, like, we're gonna throw a party.
We should do it. We'll do a special podcast whenever that's available. It's going to be a game changer for sure. So many cloud providers now, their default Linux workloads support eBPF. Fargate's one of the few remaining ones that doesn't. So excited to see that eventually, add support for that.
Just because, like,
maybe one thing oh, sorry. Yep.
yeah, I don't like when that was opened, I was really care because I was working on Falco, like it was like one of the main features I wanted to ship. Now, I, as a user of those things, I really want to be able to see what happens. Like literally Fargate, is like you don't know, like you have no way of knowing what happens. Fargate is extremely, I would say, still hostile with you. Like even if you want to just get a shell, like it's just hostile.
Yep.
So it's eBPF.
Yeah. No, it's going to be a big game changer, for sure. Maybe the last thing to ask you about on the topic of open source is maybe around, how would you, talk about building a community in open source? What does that mean to you? We're growing a community with detect.sh. Through your experience, what advice would you have to grow and build a community? Kind of how do you view the purpose and what's sort of the goals behind building a community and an open source project? I'd love to hear you kind of talk about that.
Well, the usual rules, right? That they also apply when you work with someone in general, right? Literally, you have to be kind, empathetic, like you just have to be a good person. That's the main, requisite, right? The ability to, talk to people and involve them in what you're doing, excite them in what you're doing, are just secondary, right? But because if you are not a good person that, genuinely cares for the others and includes them in what you're doing, and by including it, I don't mean only include the people that you like, but also include the people that you might not like, or the people that are not, conforming to the idea of what is good for you, right? So literally opening your mind to a different and a diverse kind of people that might just be having the same interest that you have in making, the project better or whatever you're doing better. So literally the same rules that I will think and I will hope applies to also like people working together as a job, right? But regardless that, right, it's literally if we have this prerequisite, right, everything happens, right? Because you just, get out there, do talks, involve people. People are just genuinely interested if you're building something good. And even if you're not, there are 7 billion people in this planet, you're gonna find, right? One of the things that I'm very grateful for, maybe, like people will argue that my English is not as good as Tony's. But one of the things that I'm very grateful for is that at some point in my life, I decided to just learn English. I'm Italian, by the way, like if it didn't look like. And I just started learning English and, got myself into that. Of course, this expands your ability to involve people and, get bigger communities with you and know more of those 7 billion people. That's one of the reasons why I believe that learning languages is, one of the most important things, right? To build a community, to get people involved. Because of the same reason, right? You cannot expect the others to adapt to you or to just, do it because, you did the project, right? So like to comprehend the others, to understand them, it's a good, thing to learn a new language. So you learn the culture, you learn, what happens there, and by extension become, better to work with, and do it. Like for example, with kubectl-trace, it was essentially the juice of this. Like you just like did it, put it out, tweeted about it. For a few months, I had nothing to think than that. Like it was just like, oh, we added this, we added that, and like people were just like genuinely happy and started contributing. Thoughts at KubeCon that would like immediately get accepted because it was cool. The important thing is, again, when you do a project, when you start contributing to it, or when you create one of your own, just do it for the right reasons, not for the reason of like I want to make more money, or I want to become friend with someone, or I want just you're interested in what you're doing. You have a genuine, I will say, interest. That's the most important part.
Yeah.
Having
All good things. Yes.
not
Sorry. Yep.
a side interest is not the right thing. Not because like maybe you're successful even if you have a side interest, like it could be happening, but it's not. It doesn't. I will think that it doesn't get perceived the same way, and it doesn't bring you that far. So like rather than having side interests, just try to find a way for you to have primary interests that are good for you. I would say because like you're really interested, not because you have to do it.
Yeah.
So,
I mean, it's very similar to how we started this, sort of the top of this podcast. Like most things that I have found maybe most interesting to me or most compelling start with genuine curiosity. Like it started because someone was so interested and curious about how something worked that they just invested all of their time meaningfully in making that knowledge shared with others. Like those to me are the most compelling projects. This is exactly as you described.
one of the
I do.
one of the
Sorry, go
suggestions,
ahead.
like before eBPF, you asked me about my story earlier. Before
Mm.
eBPF, before, low-level development, C++, Go, and, general system programming and, cloud native stuff. I was working as a web developer. Like my early career was, I'm a web developer. I make websites with PHP, like some WordPress website. It was like funny times. And one of the things that probably you like, if you're listening to this podcast, you find yourself in the same situation. One of the things was like, how does it work? Like how PHP works, right?
Mm.
How, like what it is. It's an interpreted language. What that means? Like it has a lexer, a parser. It is written in C. Where is the repo? Can I compile it? Can I write a module? Essentially, like if you look at PHP, the PHP source code is the Linux kernel, but for PHP. Like you can write a module, you can extend it, you can learn so many things. There are so many things that you can do. Like, for example, Apache web server versus an Nginx FPM web server. What the different way of working? What is the model that they work with? Like, it's just mind blowing. And so before I was like writing modules for PHP and this kind of stuff. It was like, I would say, um, very cool modules for Nginx, like whatever, right? And only after I discovered, right, that I could do eBPF or module for the kernel, only after I discovered about eBPF. But it was like game changing because all those things you can do them with BPF, right? And still learn how to go in depth. You can still, write a module for like you are using JavaScript right now. Go and check out V8. What is the runtime doing? You
Mm-hmm.
want the more modern one? Go check out Bourne. What are they doing there? Like, go look at the code. What happens when you write a function that gets executed? That's, I would say, it will be bringing you to a different perspective when you do the things. Not because, you just learn something new, but because you understand how you could make something that
Mm-hmm.
is done in that way. Otherwise, if you keep only on writing, your web applications, whatever, you get very good at that. But if you're looking at the VPF, you want to go to a different, so like, unless you don't want, then like keep on doing what you're doing. I'm sure that you're doing it good. So that's it.
Well, you've always been very good at not only learning new things, but sharing that knowledge. And I guess arguably in 2019, when you wrote or co-authored Linux Observability with eBPF, that was a pretty big moment of your time, like investing your time and really focused on sharing that knowledge that you have around eBPF with the world. And I'm maybe curious just to hear about, how did you get involved with writing the book and what was that process like?
Well, I must say, 2019 is the same year that where my kid was born, like my first kid was born, so it was like a little bit involved. Um, and I literally wrote the book in 2018, mainly. It came out in 2019, but in 2018 was the moment where I wrote it, and where I co-authored it with David. Essentially, we split, half and half of the book to do it. But was a lot of effort still. You don't get rich with that effort. Of course, like there are a few blog posts from people, authors, talk about the numbers, but for me, again, it wasn't about it. So I decided to do it, and I still can tell myself how it happened, right? Literally, I was at an airport. I think I was in Copenhagen, and I was literally just no, I wasn't in Copenhagen. I was going to Copenhagen. I was in San Francisco, and I was just almost about to board my plane, and I was tweeting about the BBF and tweeting about the things that I was doing, blah blah blah, all that stuff. And one person that was really involved with BPF back then was Jessie Frazel. Like she was a lot, in like tweeting about the BPF and like what can be done, all this stuff. And she was about to write the book with David, my co-author. And literally, I was like, happy for them. I wouldn't like, do you need any help, like reviewing the material, like the programs, blah, 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 all this stuff. And at that point, I was using eBPF since, I don't know, 1 year. It was, I think I started in 2017, like to use it in a way that I could comprehend it. And I was like, can I help? And he was like, yeah, you can help. And then at some point, I received this email in the airport saying like, can you write a book instead of me? Because I got like these other things to do. I think that like she was doing, I don't know, Oxide or the
Mhm.
kit, whatever she was doing, but it was very important. And the book was very, like, there were like a few pages written by her. And then I took over and, finished, those chapters. But that's how it happened. Like I didn't have any special, friends at O'Reilly or anything. Then I, became friend with my editor. I introduced a few more people that wrote books. Um, but back then I didn't have, like, I wouldn't think that the same that day I would be writing a book with them. Of course, like,
Mm.
so in life again, right? I didn't
Yeah.
think about like writing the book. I just wanted to help those people, with their book because I was interested
It,
in the technology, and they asked me to do it instead,
it's
which
amazing.
completely unplanned. But it happened, and what was one of the
It's awesome.
best thing in my career, right? So it's
That's awesome.
um,
I mean, it's a very good concrete example of the possibilities of open source communities, like what doors that opens. This is a perfect example of that. Just by joining a community of people talking about the same, technical interest, same curiosity. It's awesome, and a lot's changed, since you wrote the book, but it's still a good read, and I highly recommend folks, if you haven't checked it out, go get a copy. It's really well done. You should be really proud of that too. It's great. I'm actually kind of maybe as like
I'm
the last question
I can't be
was
proud.
that.
You know that I can't. It's like it's
Well, I will be
impossible.
proud. I'll be proud on your behalf. Um, but it's well done. It's awesome. So yeah, again, please go check it out. If you're listening and you haven't seen it, go get a copy. Um, so
But
maybe the
I want to say
last,
something to
yeah,
the
yeah.
people. Like, do you all know that Tony bought those glasses specifically for this podcast? Like, that's
I listen. All right, it's busted. Whenever COVID happened and everyone was on Zoom calls, getting different glasses was like the new fashion statement. Like your face all of a sudden is the only thing you can change, and so gotta change it up. My
because
two
now
daughters, they'd be unhappy if I didn't. So they love that I change it up. But yeah, this is just for you. Um, I want to ask maybe one last question, and then definitely, if we have time, can turn it over for folks that are on the podcast call now. But I wanted to maybe talk a little bit about problem detection. There are a lot of tools out there that are good at telling you when you have high latency, but when you truly want to understand like the underlying cause of something, it does seem like, at least from my perspective, eBPF offers up this huge opportunity to really look at the problems that could cause high latency or could cause something to crash. And so maybe one last kind of topic or question to kind of bring up here would be maybe first, is there like a memorable incident? You were an SRE for some time, or some kind of outage that you've been a part of, where troubleshooting was difficult, and if you had the capabilities of eBPF today, how would that have made it easier? Maybe you did use BPF trace or some tool in those incidents. We're just kind of anything kind of come to mind that where eBPF would have been a powerful tool in that situation to get to the root cause.
I don't have anything memorable like that, but I have something memorable. I was once locked out of a server room when the power went away, and the servers were running because they were under UPS, but there was no air conditioning, so they started like kind of burning. And I don't think that the VPF would have been helping with that. But I wish I had eBPF in there, like I wish I had like a shell in there. And the eBPF was there, because if I had it, I could at least, see what a server does when it is burning, right? It is doing when literally. And then, the fire, extinguisher set off, and it was like interesting.
Wow.
Unfortunately, I didn't have a VPF to know how the kernel was feeling when, but like the only thing we could
That's
look
amazing.
at were like the logs and stuff after the fact that were getting uploaded somewhere
Wow.
for those couple of servers that got, kind of, they didn't really burn, they just like were in a very bad state.
Yeah.
We needed to understand what were the implications. With the VPF, I think we would have been able to understand better, at least, because when servers are in a situation of extreme, like, I don't know, temperature or like adverse conditions, they tend to do things in a different way, right? There's a perfect example. Oh, like there's Brandon shouting at the disks, right, on YouTube. You can look at that on YouTube, like Brandon Gregg shouting to disks, and see the spikes in the graph of, I think, the latency it was. I would have been wanting to have the same thing for those servers while they were like going to the high temperatures, 100 degrees at the CPU core. Can always simulate that by not removing the peel out of your CPU when you mount your PC, but it's not the same thing. So literally, this is my thing. In the years, I don't think that I could have been doing without it, because when you have something, you don't miss it, right? So every time I have to do something, I immediately, go and, like, if you have a Go application and you want to know how it performs, you can use pproof. You can write a BPF program that, profiles the functions. Now that there's the profiler from, the guys, the Elastic, you can see it even better in OpenTelemetry. But if you think about it, it's just about the fact that you have it, makes it you not miss it. Like, you don't know what you have until you don't have it anymore. So I think that
Yeah.
I will be able to answer this question if people remove a BPF from me, and then I miss it. Now I will be able to answer this question, like where I where it would have been useful. Like, for me, it's useful every day. Like, every time I need to do something, you just write a BPF trace script or a BPF ROM. I think it makes you a lot quicker at executing in certain scenarios. But it's not about eBPF as alone. It's about in my case, what I learned because of that. Like, a couple of days ago, I needed to simulate high latency on the network, right? Of course, you can write an eBPF program to that, but it's not practical. But you can use traffic control to do that, like add a QDs, your network interface that introduces a delay of whatever you need. I learned traffic control because I use eBPF. Otherwise, why would I, go in depth? Specifically with that, because, as I said, it's not that you cannot study what happens. Since the BPF has a lot of places it can look at, you have a nice list of what are the places, and if you look at every item in the list, you can go and learn something about it, right?
Yeah. I know exactly what you're talking about.
Right? Because if you don't know that traffic control exists, what do you Google for?
Yeah.
So it's
That's good.
oh,
Well,
yeah.
I think we have a couple of questions from folks on the call. We probably have time to ask or ask one of them, answer one of them. And so I'll read one of the questions that has come in here around some of the uses of eBPF in application security. So that this individual is working in supply chain security. and they're trying to use eBPF to do some monitoring and CI/CD pipelines to look for malicious things that are coming in from open source projects. So just kind of curious, do you have any kind of thoughts or perspective on the usage of eBPF in application security, specifically around CI/CD pipelines?
Well, yes, as everything, right, as you will do with a server, right, where you can monitor and see whatever happens while it runs, right? You can always, use eBPF in a CI environment, like in a GitHub action, eBPF works perfectly, right? So you can use your programs there. I don't see the chat, so I, didn't read it, but I imagine that this person wants to be able to see what happens in their dependencies or what happens when they run something in the CI, which is, a valid problem because you don't know, right? When someone sends or when you, like, it's better to run it in that environment than on your laptop and get compromised. So literally, it's a good use case. Like having tooling around that, it's a good use case.
Yeah.
And I've been working on one of those tools as well in that previous job, and it was very well put, I would say. So
Yeah, that makes sense.
it's
Well, to maybe wrap things up here today, maybe the last kind of I do have one. I know I've been saying the last question. I promise this is my last question, but I'm kind of curious. What are some of the things that excite you the most about eBPF today, and what are you hoping? The vision for eBPF for the next 5-10 years. What do you have? What are you hoping kind of happens? Like, what are some things in the community that you think it would be great to see happen or evolve with eBPF? What excites you about where things are going?
well, there has been like a promise since the start of the days where like eBPF will, I would say, at least for me, replace most kernel modules, right? There are a few projects trying to create schedulers for the kernel processes using eBPF, which are very exciting. In general, all that wave of like doing that kind of things, like create a scheduler in Rust that is is using eBPF, to use that code instead of the kernel scheduler for tasks. And in general, the ability to read and to unwind, packets and stacks, and of course, the whole, getting out of the having to, add a kernel module, recompile, and I hope that in the next few years it becomes even easier to load programs and to execute them. And now, like, we have IOUring, there's a patch recently landing, I don't know if it's been merged, where they want to add a ring buffer, a generic ring buffer to communicate between the kernel space and user space without interrupts, which is essentially what the BPF ring buff does. But a generic one that can be used by other programs. And so, like, this could enable writing, for example, Fuse file systems with the BPF without using Fuse. So, like, they were kernel modules. So they are in user space, but they are kind of kernel modules because they're like, we reduce the latency between user space and kernel space. So it's those kind of things. There are so many things that are there, and of course the general fact that if you have Android, you have a BPF in your pockets again as well.
Yeah.
Just mind blowing to me. Like, you can run BPF programs to see what your phone does, which is again in the spirit of getting into depth and getting in depth with things. Is again incredibly cool thing to have. Like, you can get your phone out or look at my BPF program. this way. My Grafana dashboard on my phone, well, populated with it.
Awesome.
So,
Well, I think that's probably all of the time that we have. Lorenzo, it has been a pleasure talking with you. Like I said, I could do this with or without people, but it's certainly always good to have an excuse to get a chance to talk to you. Maybe just as a final kind of couple of notes here at the end of the session, just as a reminder to folks listening now, uh, um, for detect.sh, please join our community. Sign up for our newsletter. It's pretty awesome, highly curated digest of some of the latest things that are happening in problem detection. So just go to detect.sh and subscribe there. Follow us on LinkedIn, on X. And then also just as another reminder, this all was presented to you by Prequel, a company building detection engineer or bringing detection engineering to reliability, help SRE teams avoid alert fatigue and really preemptively get fixes out and get to the root cause. So see it in action at prequel.dev. And again, I just want to thank Lorenzo for your time. It was an honor to speak with you and get to share you with the community. And hopefully we get to chat soon. But thank you so much for your time.
thank you, Tony. I really appreciate being with you anytime. Like, let's do it again.
Yes. Awesome. All right. Thank you, everyone, for joining. We'll see you next time.